Perfect, thank you. My name is Jakub Nabrdalik, and I've been building and designing systems for like 21 years now. And the last 9 years I've spent on microservices, actually exclusively on microservices, with the last 6 years moving companies from either a monolithic application or a distributed monolith into microservices. And I would like to talk to you about this. Now, I'm just recovering from a flu, which means I'm going to talk slower. And there's much more on the slides than I'm going to talk about. But don't worry, because those slides are already online, and you'll have access to this. So basically, the slides are your notes, so you don't have to make them. Okay? Now, every single company which wants to migrate to microservices or failed to migrate to microservices already, because there's a lot of companies that come over to me saying, oh, we spent 20 million euros and we don't even have a single microservice working on production, and we don't think we will. So what did we do wrong? So basically, every single company has got a different kind of a problem. It's built in a different way. So there's not like a single approach, I suppose. However, even having said that, I kind of see similarities, and there is something I would like to share in terms of how to approach this, just because when you have that situation in your company, when you have to migrate to microservices, then at least you can compare this with my notes and say, oh, you're also doing this, I didn't think about that, or something like that, and then it might help you or not. Okay, so the first thing is, just make sure that you know why the company is trying to migrate to microservices. Because what I had before is a company with like 6 people who were saying they wanted a microservices. Now, that's not a solution for you. Why do you really want to migrate to microservices? Well, because the old system is a mess. Well, let's fix the old system. The refactoring is going to be faster. How about the system is not fast enough? Well, let's learn data locality, for example, and minimize the I/O operations. Don't build microservices when you have 6 people. Microservices are solving one problem and one problem only. You have tens, hundreds, and thousands of developers building a large system, and you're building it slow. The productivity is low. So if this is your problem, that, for example, the other competitors are moving much faster, then you want to have microservices, and you have a lot of developers, and you have a lot of points of synchronization between them. So that's the thing you have to remember. Now, when you have that, now we can approach the problem with either top-down or bottom-up. So basically, we can say, let's convince the management, let's talk with the management, redesign the architecture, and then split it out and give it to the teams to build. Or you can say, let's first hire all the good developers there who have knowledge about this, and let's build from the bottom. And both of those approaches will work, and there are actually examples of those working even in this country. However, all of them are kind of messy. So my solution, I think, is much less messy, maybe not that fast. And let me show you what I think about it. So my approach is this. First, take one team. Introduce microservices to that one team using the triangle pattern and basically get with the process out, get the product out, build those things. When you have that one team working within a company of hundreds or thousands of developers, you have a proof. And when you have that proof, then make it easy for others to follow. Why or how? Basically, we are going to make the changes in the technical operations, management, and culture. We are going to talk about this. And after that, the only thing you do is you educate people, because do not assume that somebody who built a distributed system can actually build microservices from now on. No, there are a lot of misconceptions that this person is going to have, right? Especially if you were building monolithic applications before and you want to go to microservices. There is a wiki page about what kind of misconceptions you have. Fallacies of distributed computing, it's called. So basically, there's a lot of things to educate people about. So this is a slower approach because we are first going to build it with one team. However, it's a safer approach because people will have an example. And it's much easier to work with something when you have a good example with that company, right? Inside this company. So let's say we are doing exactly that. So the first step is usually, let's design the initial architecture or whatever product we are building. Let's split it into microservices, design everything, right? Not exactly true, or I wouldn't recommend it anyway these days. I would suggest find a single process, design everything about this process, build those microservices or design those microservices, and then find another process. So basically like a triangular pattern. Do not design the whole system as microservices because you don't have to. That's one thing. So it's a wasted time. The second thing is, I have been designing as an architect and building systems for 21 years. And I have never built the system the way I have designed it. So it's, it's a nice thing to have a plan, but you don't need it. You need the plan for the next half a year, that's it. Okay, so you find a process, and what kind of a process that you want to have as a microservices first? Mostly something you have a problem with. The best one is when people are getting mad because it's so slow, so basically time to market is low, because microservices are guaranteed, when you do them right, to actually speed up the time to market. But when you choose this process, whatever it is, put numbers on this, and so basically calculate right now how it behaves or how it is supposed to behave. For example, if somebody estimates in an old monolithic application how long it's going to take to implement this, that's your number. Now let's build this and see how long it actually takes when we are doing microservices. If the throughput of the processor latency is low, take those numbers, store them, because you're going to need them in the step 2, okay? We will see about this. And if there are no other reasons except for productivity, just, you can basically ask developers and see how many of them are mad about the system, how many are annoyed, and then find out how many are annoyed after the microservices are introduced. The reason for it is because when developers are annoyed, something is disturbing them and not allowing them to work. That's basically it. So they are working slower because they are getting mad about something, right? So when you calculate the number of people, you will have hard data to show to management when you want to convince some kind of naysayers, and you will have naysayers, and I will show you even when. So after you have those numbers, because if you don't get those numbers and you build microservices, you will never get those numbers again, okay? So it's important to take them before you start. Now, let's pair up with somebody who already knows those processes. The designing of microservices, like if we are sitting here having full knowledge about the system as it is right now, and if we are thinking about what we need to build, and then we would design this, that takes a day. That's all, right? Like 15 microservices, 20 microservices, so we are talking about a single team, basically, for the next few months. That's enough. One day is all we need. However, to be able to design those microservices, you have to understand the processes. And getting that knowledge out sometimes takes 2 weeks, sometimes takes 2 months, when I have to just dig it up from the code base because nobody knows how the system behaves. Or, even worse, when people do not agree or understand what kind of changes they want at the end, in the next half a year. So basically, pair with somebody who already has that knowledge. It's much more efficient than digging it up your own way and expect the whole design phase to take 1 day. Now, when you do it, this talk is not going to be about how to design microservices. I already have talks about this, so I'm leaving you with 2 links to 2 talks and to a workshop. So basically, you can read there, and there are books there as well. So if you don't want to watch anything on YouTube, for example, then you can buy a book. And all these slides are already on the internet, so you don't have to take pictures, but if you want to, no problem. But just remember that the forces that impact splitting stuff into microservices or joining them together, basically modules, are completely different than the monolithic application. First of all, there is the code ownership and autonomy of the teams. Data locality and the number of I/O operations. You cannot have too many I/O operations. The processors are going to be slow. The transport cost, frequency of change, and uptime or SLA. So basically, these are important things. And security. So you split things because they have different security considerations, for example, or different uptime considerations, okay? And when you optimize this system, either you already know that we have something that we have to optimize for, like 20 milliseconds of response time, right? Or if you don't, just optimize for how fast it is to add new features, so that's extensibility, and how easy it is to manage this stuff. Now, when we design these new microservices, try to use tools which allow you to keep everything in a DSL, domain-specific language. So the whole architecture should be a text file. The reason for it is because then it's easy to refactor. So I recommend tools like, for example, you can use Structurizer Lite, which is free of charge for commercial use, okay? And you can put it into your repository. So basically, no networking calls to external services. It's safe to do in the bank, all that stuff. You can use Plant UML, and there is an IDE for C4, because I suggest C4 as a way to organize the architecture. It's simple enough, and there are just 2 diagrams you are interested in. And there are other tools. Whatever you do, use the tools that allow you to keep that data in Git as a DSL. And at the same time, throw away all the old tools, which makes no sense anymore. For example, Confluence. Confluence is a piece of shit which brings all the chaos inside the company. I haven't seen a single company with any kind of an order in there. So basically, it should be governed knowledge. It's a big piece of mess. That's it. Instead, move all that stuff into Git, into Markdown files, and you will see that it's not very difficult to actually review because you have pull requests, because every single developer and every single person is used to the proper Git workflow. What about the business people? Well, most likely you have some kind of a GitLab or some kind of a UI that you can actually enter and basically press a button so they can work with this as well. So that's not a problem. Then throw away Jira, because Jira is a reporting tool more than management tool, whatever else. And your teams do not need it because you have autonomous teams. Enterprise Architect is an abomination which was old 20 years ago, okay? So just burn it. And monorepo, just don't go there, okay? Unless you are Microsoft and you're working on Windows. And if you are Google, just don't use it because you have to use it, but you have no other options, so who cares? Graphical architecture design tools, you have to replace them with DSL. So if you're using Draw.io right now, don't use it, okay? Because it's impossible to refactor, okay? And DSLs are easy to refactor when you get them. Now, the first thing we built, when we built now the first microservice, and this is crucial, this is even the first book about microservices, Sam Newman wrote that book, is to create a tailored service template. And this is crucial to have it at the first microservice, because if you don't do it, what happens is that your developers, when they are deciding about whether a new feature or a new module is going to be inside an existing microservice or a new microservice, always choose the first one, okay? Because they are lazy. They think, oh, building a new microservice, that's going to take days. I have to go into Confluence and find where that page is about how do we do it, actually. And there's nothing, you cannot find anything on this Confluence, right? So instead, what you do is you create a tailored service template when within 5 seconds, you get a testing, basically a new microservice. You just have to give it a name with all the testing set up for you already. So examples of integration tests, for example. If you are using test containers, you can have their Kafka and DB, for example. Please remember to always turn on parallel test executions, because there are no laptops with one core, okay, for like the last 15 years or something. Or maybe 20 actually. So basically you will always have to use those cores, and this is off by default in many tools, right? Then you have to prepare transactional or non-transactional outboxes for communication, because people do not know how to use them, and basically if you don't, they will just ignore the whole problem of not being able to communicate between microservices. Kafka read model, there's a good reason to have an example there because it's not that simple. Then a template for a README so that you have documentation the same way. Pipelines with CD to production, continuous deployment to production every merge or rebase, and zero downtime deployment. That's the minimum. This is what you should have in your microservice tailored service template, or I have in mine. And what that means is, after you come up with the name of the new microservice, after 5 seconds have passed, you can start implementing business logic, which is exactly what you want. So the evolution of tailored service template looks like this. It's a script. It's a shell script. It's that easy. I'm going to show you how it looks like, how it actually looks like. Then you can customize this shell script if you want to, when you have more libraries or languages or whatever else. And then, at some time, you can even create a developer portal when you can actually click on stuff and basically get the microservice that you want with all the tools that you want. And I just want to point out that a website like StartSpring.io is on Apache 2.0 license, and basically you can steal that. And change this and use it in your company. But I don't do that, actually. I just set up a script. And this script is as simple as this. I'm just cloning a repository, which I have prepared, and I'm renaming, or basically calling a method in Gradle, because I use Gradle to be able to rename stuff in that repository, so you have the microservice with a good name in all the files, and then I'm pushing this to the production. And that's pretty much it. Now, what am I renaming, or basically the whole logic of this script is here, when I don't do much except for, you got microservices, they have to have the name of the microservice in several files, and that's what you have to replace. And maybe replace the file that is actually going to push this into production so that it goes into production, so your pipeline. So this stuff is easy. You can do it from the scratch in half a day or in 15 minutes if you know what you're doing already, right? But if you don't, you will not have new microservices. Every team will be like, oh, we got 3 microservices, and whenever we think about something, we add it to one of those 3 microservices, and that's it, because we still think that creating new microservice is difficult. So when we have this, you will have to create some libraries, and you will have to think about, should I put the code as inside the template, just as the code, so you can copy-paste this, or should I put it into a library? Remember this, libraries are much easier to update, but actually quite more difficult to customize, to change. So when you have code that has got to be customized a lot, I can put that just as a code inside the template. Or if I have something which I would like to update so that all the microservices just have a single change of the one number and then they have new stuff, I would put that in the library. Now, the three libraries, or one library I would do right away, is the outbox pattern, because people who are starting with the distributed systems or with microservices do not assume things to fail, and they have to, right? We know that the eventual consistency is the maximum you can get. So what that means is I create a slow outbox, and that means this could be as simple and trivial and naive version, something like I'm putting all the data that I'm going to send to Kafka to the data table, to this table in a database, and I have a scheduler which actually sends it in like 5 seconds, right? This is slow, this is inefficient, but this is simple. This is so simple. This is like AK-47, right? Everybody knows how it works. So basically, you don't have to learn anything new. And what that means, it's 100% idiot-proof. Other people will look at it, and they will understand it right away how it works. Now, that's not going to be enough. You will have some processes which need to be fast. So let's create a fast outbox, something where basically you will have something like maybe you will listen to transaction log, write a head log, or maybe you will have something like the Bezium or whatever else. Or maybe you will just try to send the message to another microservice and store the message in the outbox only when the sending fails, which also works. However, it's kind of dangerous because when somebody turns off the power on your machine, then you have already sent that message, but you don't know about it, right? So you have to think about those things. This fast outbox should be used everywhere where basically you require speed. However, it's not 100% idiot-proof. You have to actually think about this from now on, right? And then you will find out you will need another outbox, which is an outbox with ordering guarantees per key, so basically allowing you to do partitioning. And this one is much more complex than the other ones. So always prepare at least the first one, but in most cases you will have to have 3 for the developers to choose from and have a library for them, or examples at least of how to use that. And we are only talking about microservices which are actually talking outside of your, for example, Kafka or some kind of an event bus. Because if your microservices already talk through the event bus, in Spring, which I use, basically there is this retrievable topic, and there is this pattern of using topics and queues to basically do retries and dead letter queues, and it works perfectly well, and it's just an annotation. It's simple, right? But for everything else, so things like have REST communication outside, you will need those outboxes. Okay, so when you have that template, are you going to have a single template or several templates? What if you're using several languages or frameworks in your company? Do not worry. Creating a single template is what you start with. If other teams want to create more templates, let them do that. Not everybody has got to be the same, okay? Let's have some diversity here. And most of all, let's have some freedom. The important part is this work will not be lost because basically everyone else will look at this template when they want to build their own, okay? So it always pays off. So now, the next step you have, so we already have an application and tailored service template. Within that template, we need to get to production in a continuous way after every merge. And banks get scared at this point. Basically, they say, no, we can't, we're not allowed to. We have to have this manual process when somebody basically clicks on something or approves or stuff like this. Well, that's true. You might have those requirements, but we already have them implemented. First of all, to have a continuous deployment to production, you need to do left shift, which is moving everything, all the things that happen on dev test, UAT stage, and so on, within the pipeline, inside the pipeline. So it should be already there, and it's easy to do. But then, what about this manual approval that the bank requires? Well, we already have that. It's called pull request. Somebody who approves the pull request now, within the bank, for example, that's not a person who says, oh, looks good to me. I don't like this space or this comma here. That's the person who says now, this is ready for our clients and to go into production right away, okay? And banks have a problem with this because they say, oh, well, we don't trust our developers enough. Okay, then if you don't trust your developers enough, you have trust issues. That's a different problem. Let's go to a psychologist, for example. Or maybe let's hire the people that you can actually trust, right? Because maybe you have hired the wrong people. So there are different solutions to those problems depending on what they are. Just believe me that banks do use continuous deployment, and basically they have microservices, the good ones. So if banks can do it, if a company which has got nuclear power plants can do it, you can do it as well, because I don't think there are more regulated environments than that. Okay? So this continuous deployment is required. Now, after that, think about infrastructure isolation, because what we want to have, let's make it real, okay, for a moment. When you have hundreds of microservices, in every single second, on every single day, there's a lot of failures. Things break all the time. And that's by design. That's how it should be, okay? We expect this. But when we expect this, what is important is that we have separated the stuff that has to work, high uptime, with the stuff that can break. And we are making a lot of changes there. And therefore it breaks, because guess what? Who introduces bugs into the system? Developers who change things, right? So this stuff that we work on, this doesn't have high uptime, okay? Usually the uptime is high for stuff which does not have a lot of changes. But when you think about it, one team can impact another team in different ways depending on the infrastructure that you have. For example, if all your teams are working on the same database cluster, then what happens if one of those teams actually uses up 999 PostgreSQL connections? And there are no more connections for other teams, right? So that means that we would like to have a separate database cluster per team, at least. In a perfect world, per microservice, but that makes no economical sense, to be honest, so it's usually per team. But how about Kubernetes cluster, right? Well, if you are on a Kubernetes cluster, as far as I know, even now, it's impossible to limit the I/O that is being used by a single pod, which means that a single pod, which is running on the same machine that your pod got deployed, can actually use all your I/O, which means you don't have a cable to talk with other microservices, all the users. So basically, the other team is going to kill your process, right? So what that means is that most likely you would like to have separate Kubernetes clusters per team, okay? So now when we screw up, only we are suffering as a team, and we know what kind of processes we have, and we are responsible for this product or for those processes, so it's on us, but we are not destroying the whole system. And it also gives some benefits in terms of security. And security is important because we are living in a world-like times. So basically, if somebody breaks into your system, you would like them to be limited to that one Kubernetes cluster, and that's it. And then when you communicate with other microservices of other teams, you communicate through, for example, Kafka. Try to hack my system through sending messages to on Kafka. It's not that simple, okay? So it's all about isolation here. Now, the same thing with Kafka. So if you have a single event bus, I've seen situations like, for example, one team had a bug when they started to send 1.5 terabytes of events per second on a global Kafka. That means that every other team will have now a problem because there is not enough I/O for them on the Kafka brokers, for example. So how do teams or how do companies get around this? Well, what they do is they set up a public Kafka, which public means all the teams communicate through that single cluster of Kafka. But if you want to have like 90% of the communication is actually between microservices of your own team, and you have a second cluster for that. So now, if we break the cluster, there's a 90% chance that we are breaking our own cluster, meaning we are not impacting other teams. You have to think in terms of things will break on production. How do I limit the scope of things that break? So how do I isolate things between them, right? And some of those things are kind of tricky, like, for example, logging aggregation, because you actually want to have logs in the same place. And that means maybe some kind of a logging federation. I actually haven't seen a single company do that. So basically, this is just purely theoretical, but it kind of makes sense to me, because you can also use up the logging system, basically, use all the resources of that system. Okay, so we got this. Now let's go and actually make sure that when we are setting up any kind of Kafka or any kind of event bus, we know we have like a naming convention. That was my failure from years ago. If you don't have a naming convention, then you don't know which topics are for communication inside a single team and which are between the teams. And that's a problem because sooner or later somebody is going to steal your events and you will not know about that. And therefore, because you don't know about that, you're not going to support them. So basically, you're going to one day turn off that topic and basically move on to another one. And then some other parts of the system break because they were thinking, oh, this is a public topic. No, it's not. It's my own, right? So you have to have a naming convention to make sure that everybody understands what they can use and what they shouldn't. And then you have to set up the security here. And that means, well, in banks, for example, they often tell me stuff like, well, we cannot allow developers access to production, right? And I say, like, how are we supposed to work then, right? It makes no sense. Like, if you run my code, this is my machine now. There's no way to protect against me when your machine is running my code. So you can just basically give it away to me. And so what happens and what actually makes sense is to understand that all the changes in your production system should be done with a pipeline. So basically no manual changes there. However, if you want to look at the system, list the number, all the pods that I have, go into the machine and look at the logs. So basically all the kubectl read operations, you should be able to do it. In the same way, because otherwise you can't debug this shit. And when things break, you will have like an outage of hours instead of seconds, right? So then the next thing is developers have to have access to production data. And that's also a problem for a lot of companies who never thought about it this way. They are a bank, so basically they say, we cannot allow developers to access the production data, right? Well, if you don't, then I'm going to log that shit out in my logs. So basically I can see what's going on because I need that data to be able to debug. So again, you cannot protect against me. What you can do is make my life harder, but it makes no sense. But then the bank says, for example, okay, but we have developers and we don't trust them enough, right? So how about this? What if your team has got 7 people and 3 of them are senior people, then 2 middle developers, and there's like 2 junior developers, right? I completely understand you don't want to have junior developers who are working here for like 3 months, still on probation period. You don't want them on production data. Fine, don't give them that access. But give the access to everyone else, especially to the people who are already working there hard for like years and years because you should trust them. If you are still hiring them after 5 years and you don't trust them, what the hell is going on, right? Something's really fishy here. So you can split your developers into levels of access. That's completely fine. And now you have to think about 24/7 on duty. And how do I make it possible for the person who is going to get the phone call from some kind of a service about, our system not working? How can they access the data on production? Because that's the only way to fix stuff. And you can require them to pair with somebody else, but then you have to make sure that this is legal because it's actually not that simple because 24/7 on duty is a tricky thing. So basically my suggestion is by default give them access to production, but only to those databases which their own microservices already have. So basically within the team, because they already have that data. They can get it any way they would like. And if you don't trust them, fine, let's make pairs with senior guys. So basically those people will be fine. Okay, then you have to make sure that you turn off all the other stuff because I have seen companies hacked by leaving Kafka admin API or panel. So basically somebody just removed most likely a developer who got fired or something like that, removed all the not me, all the pipeline, not the pipelines, all the topics, right? And even created a topic saying you probably should protect your with a name. You probably should protect your admin panel there. So stuff like this, right? Okay, so that's the approach. You have to think about it. Other people's will not. When you have this, the next step is to prepare the monitoring and observability and give them examples. Most developers have no idea about how to do that, and some of that stuff is for free right now. It's kind of hard to actually break, like tracing. Some of that stuff, like metrics, you have to actually think about what kind of a business metrics you are going to have, because technical metrics are already there by default, by the framework, for example, so that's easy to get. But business metrics, people don't think it this way. So make sure that you have prepared dashboards and you make them public so people can actually watch how you have created them and how to use them. And here's the problem. If you are the only person in a team, let's say we have a team of 7 people, and you are the only person who created this dashboard, right? And you're on every single meeting or every single problem, you are basically looking at this dashboard and showing to people, they will never learn how to use this dashboard by themselves. So it's 3 a.m., you're not available, and they have a problem, they won't be able to manage. So how do you do this? Well, the process that works for me, even though I would love to have another one because it's kind of ugly, is to every single day within my team, in the morning, one person, every single day of the week there's a different person, right, has to look at the dashboard that exists already, analyze all of this, analyze all the trends and the situations, and the stand-up starts with that person explaining what's going on in production, okay? And that's a new person every single day. So if you have a team of 5 and you have 5 days in a week, that's perfect. Now, that's a burden because you have to analyze this before you actually start your work. At the very beginning, it's going to take you 45 minutes. At the end, it's going to still take you 15 minutes to understand, to analyze all the dashboard. However, what it will make is that every single developer will be able to understand every single metric so that they can fix the system when it breaks in the middle of the night and they are on duty, right? And that's the only way I know of how to make them understand this dashboard. If you are the only person, or you have a QA, and that's the only person that actually explains what's going on in production, people will never learn. Okay, so the next step is to decentralize the knowledge governance. So basically, microservices has these assumptions that teams are autonomous and basically the knowledge is decentralized, which means that the tools like Confluence, you can get rid of them, but there's a lot of different tools that can help you out. I'm using Obsidian that I actually learned from AWS. This is a perfect tool because what it is a text editor for your nodes with Git underneath. So there's just a typical repo and you're storing everything as Markdown. You want to keep for a single team, keep all the knowledge there, so like it's easy to access and you have a tool which you can write, like it's really, really easy. Like you cannot actually find an easier tool. That's your tool, that's all you need. And you only need a Git repository there, it's perfect. Now, the architecture should be in the repository as well. The documentation should be automated as much as possible. And then when you are large, when you already have tens and hundreds of microservices, then most likely you will go into something like Backstage or any kind of a tool which will actually aggregate all those readmes, all those files, and allow you to search through all your microservices because you already have 2,000 of them. So basically, there's a lot of products, right? And that's why you never need Enterprise Architect anymore. So now, when we do this, there is another thing. And this is actually the tricky part. Remember when I told you that you need to put numbers on how happy are the developers, or how fast is the process that you're changing, or maybe how slow it is to implement it in the old system. Well, this is because right now you will have this problem about managers not understanding that microservices actually require a lot of changes in the culture and the management, okay? For example, there is this thing called micromanagement, and it kind of fits microservices, right? Micromanagement, microservices. No, it doesn't. It's an opposite thing. Actually, it actually does not work at all with microservices, right? So we're going to have to explain it to them. And I have some failures in explaining this to management, but I have some successes. And these days, I give workshops on microservices and architecture, right? And to my surprise, companies who used to hire developers and architects and give them to me so I can train all the architects and developers, now they say, okay, so you've already trained all the architects, let's train all the middle management. And at the end of the day, let's train the board. How about this? About microservice architecture. What? Well, they start to understand that it requires a lot of changes in the culture and management. So how do we talk with them? So here's the thing. It's kind of hard to explain unless you have a good story. And I have worked out through the story, and it goes like this. From now on, if I have to explain to managers how your job changes, you're the managers, I'll tell you this. You are now no longer managing people. You are no longer managing any single thing except for the big things, and that is money. The first thing is you are a venture capital. You have a lot of cash, and there are products that need to be built so that we can earn more cash on the market. So you are a venture capital, and you decide about startups, and you invest in those startups. Those startups are actually your teams. That's your product teams. Whenever you invest in this kind of a startup, you need to verify whether the startup works okay or not. But you do not go inside the startup, and you do not try to change any single process or how people work, because you don't care. You only care whether the startup works as a whole or not, right? So basically, you are a venture capital. What that means is these are the decisions that you make from now on, and there are only 4 of them. The first one is, do we need to create a new product? Because, for example, let's see, oh, the market is moving in that direction, or our competition did something like that. Maybe we need a product for this. Or maybe we already have a third-party product, we don't like it, and we have new features. So maybe we can invest into that and then, therefore, get more money from the market. That's your bet, okay? Now, the second thing is, do we have a team that we can give that product to? Or do we have to set up a new team, right? Well, you can have a single team having like 2 products or maybe 3 products, but people are people. They're not going to work on 3 products or even 2 products at the same time. However, you can have a situation when the old products, they don't have too many changes. There's not much to do there, right? So maybe a new product will be actually fit into that team. If you don't, then you need to create a new team. Then the third decision you have, should we keep funding this product? So basically, there are people that are working hard and they're building something, but it's not making any money, right? So maybe we made a wrong decision. Our bet was wrong. So basically, we are saying, no, we are going to scrap this and not build that product. Google does it all the time, right? Even if it makes money, but that's Google. And then the decision that you have, should we disband this team? Because, for example, maybe this team doesn't work well. Why? For example, there is a team leader which is an alpha male and he fights with a sigma male, for example, or whatever else. You don't have full release men inside this team, so there is always some infights, right? And so you can decide that, yeah, this setup of these people doesn't work. Let's fire them, or basically let's disband the team and let's build those teams in a different setup, for example. You can do that, but you will have microservices or products which are left over, and that's okay. We can actually manage this. Now, all the other decisions are within the teams. So, for example, one of the first things that you're going to see when you start working with microservices and product teams is that developers do not report their time. If you have a tempo or any kind of a tool which you are reporting, you know, how much time you spent on building something, right? Nobody cares anymore. Why are your managers actually caring about how hard you work? Because, well, your work is not directly connected with revenue. So basically, they estimate about how much revenue you can make out of your work by seeing how much you're busy, right? So the more you're busy, the more you're tired, the better, the more work you did, most likely, right? It's not exactly how it works, because you can be very tired or very productive in creating a lot of code that doesn't bring anything or even make the situation worse, right? And we know that. So with microservices, when you have product teams, management is not interested anymore in that. Instead, what they are interested in is this product making money. Okay? Should I keep investing in that? Should I pay your money for your salaries so that I get something out of it? And if you lay on the beach for half a day, then swim or basically do whatever you want, and at 3 a.m. or 3 a.m. in the night, you basically come up with an idea, then you code for an hour and a half, and it makes 10 million, you're a perfect developer. And so you never report your time. And I'm telling you how it really works. If you are in Poland and you're saying something called KUP, because you're fully employed, well, I feel sorry for you for that, but if you do this, then remember that you only have to do it at the end. You have to fill those forms at the end of the month. You don't have to fill a tempo with every 15-minute task you have with this, okay? So a team makes all the decisions within itself, okay? And what kind of the decisions are those? How to spend the budget, for example. So basically, I know I have money for about 5 people. What kind of people am I going to hire? That's an important question from a perspective of a startup, the same from a product team. The team controls the product and strategy, which means in reality that, so we are creating a registration. We are the registration team inside, let's say, a telco. And so the telco has got sub-brands, and we are working for all those sub-brands, and these guys want something new. And it doesn't fit our product. Can we tell them to fuck off? Well, if they are making only 5% of our revenue, and implementing this would actually make the whole situation messy, and we would have hard times actually keeping up for the customers who are 95% of our revenue, then it makes perfect sense, okay? So it's a completely different dynamics. It's like you are on a free market and you are one of the companies, your team is one of the companies that are working on this market and you are offering your services. If you say fuck off to every single business unit, you're not going to have clients. You're going to get disbanded and fired. But if you have good clients and you cannot build everything for everyone, it's completely fine to say no sometimes, okay? Then you have to control the backlog and apply for more funding. So one of the shocks I had when I moved into microservices was that nobody actually does like a 360 or review how we work, how hard we work, right? But it also means, because nobody even is interested in whether we work hard, they're only interested whether the product works. But it also means that all the marketing for that product is on me. Okay? I'm responsible for the marketing. If I don't tell my managers, hey, these are the numbers that went up, right? These are the metrics that we see. And I start every single demo. If you have like a sprint and you have a demo at the end, right? Start with 3 minutes of showing the improvements from the perspective of the business in terms of numbers. And this is what your managers are going to watch for, right? And they will say, okay, so we thought you do nothing, but it seems that your recommendations are actually bringing more money. And so there's a point in actually paying you more. And if you, so basically this kind of a marketing, you have to do it. And it's as simple as record every demo that you do to your clients, if you're working with sprints, for example, and also start each of those with a message to management, because they are only going to watch the first minute and a half, that's it. Right? Then show the stuff to the business people because they are on the meeting there, they just called you and basically they want to see what are the new features. And then, if you really need to, talk about the technical details about how good you are about building stuff the way you do, okay? And that's it. And if you record it, then that will be enough marketing for now. So, how do you create such product teams? Building product teams is not that simple, but you always start with a team leader, okay? So basically you find one person, when you are a manager, you find one person that you trust, that is capable of actually doing this and leading the people, and it doesn't have to be the best technical person, okay? This guy or gal has got to understand people, most of all, and products, okay? Now, they have to be technical somewhat, but they don't have to be the best technical expert there. And then you let them, then you give them a budget, and then you let them hire more people, basically tell you what kind of people they need, and that's pretty much everything, right? And then you let them grow. So it's like a free market. It's like within my corporation, I have a free market of teams. These are my products, and these are like companies that I can fund or I can defund, whatever I like, right? And they have to live on that market or die, and that's it. And it's not like everybody is ready for this, but the microservices, to be honest, are not good for everyone. And most of all, there is this situation in some companies where if you look at how many developers we get, right? New developers from a university, like most of the people in our industry are young people, are inexperienced, okay? And it has got to be this way. And it actually gets worse every year because there are more people in the IT because IT still makes money, right? So if you want to earn easy money, you go to the IT, you become a developer, for example, and that's how you get more people. But microservices are not very good for young people, or not the young people, for junior developers. That's the thing. Why? Well, here's the thing. This is a list of tools and knowledge that a team needs to have from my last 6 years or 9 years of working, basically 9 years, right? Now, I work usually with Java or JVM, and I build systems based on Spring most of the time, so it's like limited, but still there's a lot of stuff there. Like, my team needs to handle 4 programming languages usually, 3 to 4, on the JVM. They have to understand requirement analysis, so basically how to write behavioral scenarios, how to do test-driven, behavior-driven development, contract testing, performance tests, stress tests, all that kind of stuff. They need to operate Kubernetes. They need to be able to write, modify the pipeline, or at least understand how to do it, because you don't do it that often. Then they have to understand observability, how to log metrics in a fast way, right? They have to understand how to use the dashboards, how to do remote debugging, how to handle architecture of microservices, how the Kafka partitioning works, for example, and what are the communication patterns inside Kafka. And then they have to know how to write documentation, technical documentation, and know how to do Scrum, right? And when your team is 5 people, okay, that's all they need, but it's all for 5 people. If half of your team is junior guys, then it means you only have 2.5 person who needs all those skills, right? And there are not too many people on the market who have all those skills on a high level. I'm working here for like 21 years now, building stuff. In theory, I know all those things. That's not true. I'm not that good in actually designing those dashboards. I'm really good at reading them. I'm really good at, modifying them. But doing this from the scratch, I'm not an expert on, for example, Azure application insights on Azure, right? I'm not an expert on Datadog. I can do it, but I'm not an expert, right? And I've been doing this for 21 years. So if you have a company which has a setup of 50% are junior developers and 50% are mid and senior developers, the situation will not work with microservices. In fact, the situation I had was that the company hired like 15 people from Pakistan to join us, junior developers. And after first month, the feedback from all the architects and lead developers was, this is taking much more time from our time, basically, than it's giving back in the value. So basically, those junior guys, well, we can keep investing in them, but the return time is about a year or 2 years, okay? Because they have a lot of tooling to learn, a lot of things to learn. And right now, we don't have kind of time to do that because we need to be fast, we need to deliver, right? So the managers decided to fire all these 15 guys from Pakistan, and actually development sped up, right? But it's kind of a shitty thing to do, to hire these people and then fire them right away. So just remember, the setup I would recommend, because we need some junior people, because otherwise this will not work. I actually had a team where there were 7 people, and 6 of them, 7 people in the IT, the developers basically, 6 of them had a Scrum Master certificate, okay? 5 of them had a cloud certificate of some kind, right? So really senior people. But I suggest that you have maximum one junior developer within a microservice-based team, because then you only have 5 other people that have to have all those skills together. Now, what happens if you can't? What happens if you don't have that? If like 30% of your company is junior developers? Well, there's a thing to work around this. Well, it goes like this. Microservices have been here on the market in Poland for 10 years right now, or maybe even more, a little bit more. So what that means is that you can find any kind of an expert that you want on the market, and you can call them and ask them to help you out with something for like half a day, or maybe a day. And it's going to be very cheap, because one man day is not that expensive, okay? So if you got no security experts, and you are in the phase of, oh, let's design new stuff, right? Hire a security expert already there on the market for 1 day, because that's all you need. If you need to set up, because you decided to, I don't know, have a unmanaged Kafka, so basically you're going to manage Kafka by yourself, and you are setting it up, and this is the first time you do it, hire a guy or gal who already have this system for like, have been working with Kafka for 5-10 years, okay? Just for 1 day, to verify how you did that, and basically to teach you about how to do it better. So basically just 1 day. And right now, if you have a problem with architecture, the same thing. Actually, companies call me now for like, we would like to buy like 4 hours per month from you. Is it possible? And I say, sure, if we can fit it out somehow in my schedule. Sure, why do you want to do it? Well, we are designing a lot of stuff during the month, but we want to verify this before actually implementing this, because otherwise we are wasting a lot of money. And you know, your prices are not that high. For 4 hours, it's not much. We are actually losing much more when we make a mistake, so why not? So it's easy to do. You can find any kind of expert on the market that you need. How do you find them? Here, on the conference. Look at the people who are giving talks. talk with them, and they'll give you more names. If they are not the guys, then you will find more names there. So you can watch out basically on the conferences, and you'll find people who already say like, oh, I've been doing Kafka for like 10 years now. Or I'm an QA expert with expertise in left shift for like 6 years now. Get them, okay? It's gonna be cheap. Now, after you do that, and now we design the architecture, remember about minimizing when you are splitting the system, or basically deciding how the system should be composed, of what kind of products and what teams should handle what. Please remember about cognitive load. This is the most important part. If you ever feel in your at work, that it's difficult to do because there are so many things into your head and your head blows up, there are 2 options there. First, you have a bad day. That can happen. Maybe tomorrow it's going to be better, right? You had too much coffee, and maybe tomorrow you're going to have clear thoughts. Second, you have a way too large cognitive load, meaning limit the cognitive load first, the things you have to put into your head, and then try to work on this. So how do you do this? By divide and conquer, by splitting stuff into smaller parts, by basically building teams that do not have to understand too many things at once, right? So different domains, how about just a single domain, so it's easier for you to understand? Well, we have those tools, and they're kind of problematic. We don't know how to handle them. How about I'm going to build you a team which will provide you with, for example, I don't know, this database as a service so that you don't have to think about it. And you don't have to think about replication of this, right? All this kind of stuff. Design the system so that the cognitive load is the lowest for every single team, and you're going to see improvements in productivity, right? And then we have time for consumer-driven contracts, except we don't have much time, so I'll just say, as I promised to Marcin here. Okay, so I'll just say this. At some level, at some size, you're going to need contracts, consumer-driven contracts like Pact.io or like Spring Cloud contract for your microservices, because it's going to save you a lot of bad time when people do not agree with stuff. And if you think you can get away with schema registry for Kafka, you will not, okay? It works in a completely different way. But you have to introduce them so that when you know that your microservice is not going to work with another one within the pipeline just before getting into any environment, but you will have doubts, and I had doubts. What if all my developers are so nice to each other and are working so well together that we never have actually violated any contract? Does it make sense to have consumer-driven contracts there? Okay, does it make sense to keep up all those Pact.io tests, for example, or Spring Cloud contract tests? And the answer is, well, the more cultural differences you have between teams, the most miscommunication you're going to have, and the more you need those contracts. So if you are only people from here, maybe we don't need them, right? Wrong. I have seen people work like in a company which valued diversity. I have seen people who were shouting at each other because some teams were from Warsaw and some teams were from Krakow. And the teams from Warsaw were saying, like, what are those stupid people from Krakow? And the people from Krakow would say, what are those idiots in Warsaw doing, right? And there was a lot of bad blood, even though in theory the culture is the same. Okay, so when I say culture, I mean so many things that can go wrong. If you are old enough, maybe you remember Atari and Commodore and the holy wars between people with different computers. Okay, that's a culture war. And that's enough that you need, right? So basically, contracts are protecting you against people having different opinion and miscommunication. And if you don't see any of those teams violating those contracts, it's because you have them. So they know if they violate the contract, it will blow up, they will see it, right? But if you don't set it up, then sooner or later, people will basically start screaming at each other, somebody will fuck up, and some other team will pay, and they don't like that. So basically, design, and remember, you will have to introduce consumer-driven contracts at some point, maybe not from the very beginning, because it doesn't make sense to do it within a single team, usually, because that would be a really bad team. But between teams, you're going to have miscommunication, just like in your marriage, so you have to have contracts, just like in your marriage. Okay? All right, and then you will have to enjoy, because at the end of the day, if you go through all of this, what you should expect is, let's say productivity will increase about a factor of 4 times. That's the numbers I kind of could see. So now we are talking about we are delivering stuff 4 times faster. That should be this. The next thing you're going to see is that Well, we are going to have more technical tools and more technical stuff, which is a great thing for developers that like to learn. And then you're gonna have to see people have less stress at work. Why do they have less stress at work? Because managers do not play such an important role, and they don't do micromanagement. And managers are the main reason of stress at work. The other reason why we have stress at work is communicating with other teams. And we have contracts for that. So now we don't have to talk with any people except for my clients and my team. And it's easy, okay? Or much easier than anything else. So you're going to enjoy this. And at the end of the day, this is the link to everything I just shown. That's the link to the presentation and to the talks I've already given about the real architecture, what kind of stuff that happens when you're moving to microservices. Thank you very much.